Today we are going to see the hydrology. These are some parts, definition of runoff, portions of runoff, runoff process, surface runoff, factors affecting runoff. These are some portions, the conditions of runoff cycle, summary of rainfall and runoff process. Definition of runoff. The runoff can be defined as the portion of the precipitation that makes its way towards rivers or ocean, etc., as surface or subsurface flow. Portion which is not absorbed by the deep strata. So these are the important terms. You will study that one. The runoff occurs only when the rate of precipitation exceeds the rate at which water may infiltrated into the soil. The portion of runoff, the surface runoff, groundwater flow, direct precipitation over the river stream. The runoff process, when rainfall occurs, some part is stored. The depressions on the ground surface known as the deposition storages, which later infiltrates or evaporates. When rainfall occurs, the part of rainfall precipitation is intercepted by vegetation. Some part is stored in depression and on the ground surface known as depression. Some part of rainfall is absorbed by the soil, the amount of which depends upon the soil moisture condition at the time percolation. Percolation means the penetration, the water penetration into the soil. Now, if the drain continues further, the water start infiltrating, percolating. So these are the important words: infiltrating, percolating. Normally the same word to the water table, and if the rate of rainfall or the rate which the water is reaching the ground exceeds the infiltration rate, resulting the surface detention. This water flow over land and joins river, lakes, streams, oceans, and known as surface of runoff. So, in area, according to irrigation technology, the runoff means the important. So, we have some calculations and so many definitions are there. Runoff coefficients and this. So, basically, you have to understand what is the runoff, the portion of precipitation flow to above the surface, not subsurface. Surface means the above the surface, above the soil plates. So you can understand, right? Then one can say runoff has surface runoff. The surface runoff is important for maximum flow, whereas the groundwater flow is the important for minimum flow. Direct precipitation over the river or stream is negligible. So for peak flow, we are generally concerned with the surface runoff, and therefore we can say runoff as the surface runoff. Then this is the important. I may ask the question: the factors affecting. So I may ask you, what are the factors affecting runoff? So you can write these 7 points. For I will ask for 6 marks. The precipitation characteristics, shape and size of the catchment, topography and geological characteristics, meteorological characteristics, character of a catchment surface, storage characteristic. Okay, these are the important factors. Do mind it. The precipitation characteristic, it is the most important factor of runoff. Runoff depend on the type of storm. Storm means the heavy rain we can call as heavy rain, and it is duration which causes precipitation. Runoff depends on the intensity of rainfall. More the rainfall, more will be runoff. If the rainfall intensity density is very less and it rains as light source, then much of the water will be lost in the infiltration, evaporation and resulting less runoff. So I already told what is infiltration, evaporation. The precipitation is in case of snow, then less runoff, right? Shape and size of catchment. The runoff depends upon size, shape and location of the catchment. Generally, more rainfall on smaller area resulting greater runoff. Less runoff in larger catchments because due to uniform rainfall over the entire area. Thus, only few tributaries of the stream feed water to main stream during a particular storm. The types of catchment: the fan-shaped catchment, firm leaf catchment. These are the types of catchment, right? Fan-shaped catchment. All the tributaries are approximately of the same size, give the greater runoff because the peak flood. The peak flood from the tributaries is likely to reach the main stream approximately at the same time. This is the fan-shaped catchment. So you have to understand what's the catchment area. Catchment. This is the waters come from the water segment area. So during the rainy time. So catchment gives greater runoff because the peak flood from the tributaries likely to reach the main stream approximately at the same time. Fern leaf catchment. The tributaries are generally of different lengths and meet the main stream at the regular intervals. Such a narrow catchments, the peak flood intensity is reduced since the discharges are likely to be distributed over the long period of the time. So you have to understand what's the difference between the fan shaped, this is the fan shaped catchment, and the fern leaf, normally leaf catchment. This is the mainstream and branches are there. So, such a narrow catchments, the peak flood intensity is reduced since discharges are likely to be distributed over a long period of time. The topography runoff depends on surface smoothness and slope. If the slope is steep, flow will be quick and less evaporation. So these are the important. I oftenly tell evaporation, transpiration, and absorption is a main important factor. If the catchment, so this is the very important word in the irrigation technology, catchment. So you need to understand. If the catchment is in mountain areas and on the windward side of the mountain, then more rainfall resulting more runoff. Okay. Geological characteristics. It is the one of the important factor. It includes the type of surface soil, subsoil, type of rock, and their permeability characteristics. If soil and subsoil is porous, seepage will be more, resulting reduction of the peak flood. If the surface is rocky, then absorption will be nil, resulting more runoff. If rocks have fissures, are porous in nature, have lava, funnels, water will be lost, resulting less runoff. Meteorological characteristic. Runoff may also be affected by temperature, wind, and humidity. Meteorological. So, that's the meaning the meteorological predictions, weather forecasting, the meteorology. So, these are the something, right? Meteorological characteristics. We can see the meaning. I mean, what is the meteorological characteristics, right? It's a simple portion, so you can understand, but You have to memorize some important terms. This the catchment. Who? Wait. So if the temperature is high and greater wind velocity give rise to greater evaporation loss and resulting in less runoff. So meaning you can understand what's the meaning, the runoff, the portion of precipitation during the flood time. So it's easily simply you can understand, right? The temperature is high and greater wind velocity, evaporation loss and resulting less runoff. So as per the dam construction, the dam locations during the rainy time, the water comes to the dam. The portion of the incoming incoming flow, the portion area of the incoming flow is called catchment area. So it's an important term that you can understand what I was saying. Okay. Then character of the catchment surface. So catchment area, these the two very important, right? Okay. The runoff depends upon the surface condition like drained, undrained, natural, cultivated. If the surface has natural drainage, then absorption loss will be more. If the more area of the catchment is cultivated, resulting less runoff. Vegetal cover reduces the runoff in smaller storms. No vegetal cover reduction in brick storm, right? Then storage characteristic. The artificial storage such as dams, weirs, the natural storage such as lakes, ponds, etc. tend to reduce the peak flow. Peak flow means high flood, higher velocity of flood. So you can you studied in the flow. What's the unit? The meter cube per seconds. The peak flow. We will see the unit height flow. You can understand what's the meaning of the peak flow. Unit height flow. This is the important part. We will see next chapter. They also will raise to evaporation losses. Runoff cycle. It is the part of hydrological cycle, the part between the precipitation from the atmosphere over land areas and its subsequent discharge through the streams, channels, right? The conditions of runoff cycle, end of the dry period shortly after beginning of rainfall, near the end of the isolated heavy rainfall, after the end of rainfall. Okay, this is the end dry period. At the end of the dry period, just beginning of the heavy rainfall, all the surface and channel storage gets depleted expected from lakes, reservoirs and ponds resulted from the previous rain. So you know is the dry and drought area. What's the meaning drought? Drought. You heard about the dry zone area. Yaparea is a dry zone area, you know. It's inadequate of rainfall. It's called the dry means a VL is a cold, you know. Dry yeah, VL is called dry. Okay. The only source stream flow is the groundwater flow entering the river flow. So catchment, what again a catchment? Catchment. Catchment means jala posagaya. So you can understand this, you easily understand this. Jala posagaya called Jala posagaya. Jala posagaya. Catchment area. Focus Pradesh means catchment area. Okay. Then shortly after beginning of rainfall, shortly rainfall and before interception, depression and storage have been satisfied. The stream flow intercepted by vegetation and buildings can't contribute to runoff. This intercepted water is eventually returned to the atmosphere through the evaporation. At this stage, a part of precipitation falls directly on the stream, which gives an immediate increment to stream flow. What's the meaning? Stream flow. Yarava. Stream means Yarava. Yeah. Shortly after beginning of the rainfall, shortly the beginning of rainfall and before interception, depression storage have been satisfied. The stream flow intercepted by the vegetation and buildings can't contribute to runoff. This intercepted water is eventually returned to the atmosphere through the evaporation. At this stage, part of precipitation falls directly on the streams, which gives an immediate increment to stream flow. Okay. Near the end of isolated heavy rainfall. Isolated heavy rainfall. So we can see ice. What's the meaning? Isolated. Hudakala. Hudakala. Isolated system क्या है ना Hudakala Hattadiya Kutaka system Hattadiya. Okay. Heavy rainfall, and after many hours of heavy rainfall, virtually all depression, storage, and interceptions requirement. What's the meaning? Interceptions. Pada cream interception requirements gets filled up. The soil moisture deficiency is also satisfied to considerable extent. Infiltration rate is near the minimum. Similarly, the flow to the field depression is essentially balanced by over land flow and infiltration. Thus, it this at this over land flow mainly contribute to stream flow. Subsurface flow also contributes to stream flow. After the end of rainfall, when the drain and overland flow ceases, top stream flow consists of only base flow and channel storage. Evaporation takes place quite from soil moisture. Transpiration and takes place from vegetative cover. Water from depression storage also continues to infiltrate. Also, the gravity water still not drained up to the water table continues its downward journey to join water table. When a rain starts falling, it is first of all intercepted by building trees and other objects which prevent it from reaching the ground. This quantity is known as rainfall interception. Since this quantity is generally very small, it is not of much importance for intense rains, but many times large portions of uh, light rains are disposed of in this manner. The difference between the total rainfall and that which is intercepted is called ground rainfall. When the rainfall rates exceed the interceptions rate, so it's a important term. Rainfall interception. So what's the interception? Bata cream. Interception. So it's everything interception. So intercept the rain intercepts intercept the bus. So for an example, the difference between the total rainfall and which is intercepted is the called ground rainfall. When the rainfall rate exceeds the interception rates, water starts reaching the ground and infiltration to the subsoil starts. The maximum rate at which the soil in a given condition can absorb water is known as infiltration capacity. The excess rainwater gets collected into the innumerable small and large depressions existing in the basin. So this is also an important term. The basin, innumerable small. So numberless. Innumerable කියන ගණන් කළ නොහැකි Asangyada, asam, asangyada, asangyada කියන innumerable and small and large depressions existing in basins, filling them to their overflow. This levels quantity of known as depression storage. These are the important terms. All this storage either evaporated or used by the vegetation or later infiltrates into the soil. None of it appears as surface runoff. If the depression storage is filled, the rain intensity P continues to exceeds the infiltration capacity of the soil. If the difference appears as rainfall excess, which initially accumulates on the ground as surface detentions and then flow as the overland flow on the basin surface. Before entering the stream channel, the water that reaches the stream channel of a basin in this manner is called surface runoff or direct runoff. The surface runoff can therefore occur only from those storms which can contribute to excess rainfall and are simply not dissipated in fulfilling interception, depression, storage and infiltration needs of the basin. Key needs of the basin. Basin means what is a basin? Not a plate. Drainage basin. Thronia කියන basin. So in English, the basin, a natural depression on the earth's surface, typically containing water. So normally called Indian Ocean Basin. So you can understand easily this one. A natural depression on the earth's surface, typically containing water. So synonyms, the same words, valley, bed, channel, concavity, trough. So called same meanings. The basin, a natural depression on the earth's surface, typically containing water. It's a cold basin, right? The sum total interception and depressions. So storage for a basin is usually called initial loss or basin loss, initial basin discharge. The excess rainfall can therefore be represented as excess rainfall is equal to rainfall minus initial basin loss minus infiltration. The sum total of initial basin loss and infiltration is called potential infiltration. Okay, so you have to understand the infiltrations, coefficient infiltration, excess rainfall. So some of the little bit difference rainfall and infiltrations. Rainfall intensity, there are some definitions, so understand, right? Since the intense rain's initial loss is very small as compared to excess rain, it is usually ignored in the hydrological analysis of such rainfalls. Is considered to be included in the infiltration itself. The excess rainfall is thus represented as excess rainfall is equal to minus rainfall minus potential infiltration. The rain that falls in beginning of a storm before the depression storage is completely filled is called initial rain. The rain that falls near the end of the storm at rate less than the infiltration capacity is called residual rain. The intervening period is the net supply interval. The infiltration occurring after net supply interval is called residual in the infiltration. So you have to understand first of all this what's the meaning in infiltration. මොකද කියන්නේ? Infiltration. Infiltration. විනිවිද ජාම කියන infiltration. Okay. විනිවිද ජාම infiltration. So in English meaning look up details. The definition of infiltrations, the action of entering the gaining access to an organization or place. Sorry. This one. If infiltration means the permeation of a liquid into something by infiltration. Filtration. So improve. So on an example, improved water infiltration into the soil. So you can understand the infiltration. So this is the water infiltrate into the soil. So it's called infiltration. The rain that falls in the beginning of storm before the depression storage is completely filled with the cold initial rain, and the rain that falls near the end of the storm at rate less than the infiltration capacity is called residual rain. The intervening period is net supply interval, the infiltration occurring uh, after the net supply interval is called residual infiltration. So, you have to understand what's the meaning of infiltration. So, important thing, rainfall infiltration, rainfall intensity, right? The runoff and surface runoff are two different terms and should not be confused. A runoff discharge or stream flow includes all the water flowing in the stream channel and at any given sections, while surface runoff, this one very important term, the surface runoff, you memorize that one. The surface runoff or direct runoff, they includes only water that reaches the stream channel without first percolating down the water. So these are the very important word, the percolating down to the water table. Surface runoff or direct runoff. Percolating. So the percolating. Liquid percolate means the liquid filter gradually through a porous surface of the substance. So same synonyms words. These are the leak, drain, filter. So same word. Percolate, filter, right? මොකද කියන singular word. Okay. Percolate. Right, percolating this one, and then down to the water table. Yield of the drainage basin is the same as runoff, with the only difference that is expressed over long periods. Runoff is expressed for the short period. So this is the important surface runoff and direct runoff. The yield of the drainage basin is same as the sum. The only difference that is expressed over long period. Runoff is expressed for the short period. So this is the formula. So you need to understand, but first of all, this one. Runoff is equal to surface runoff plus groundwater inflow. This is some for an example. Total hydrograph base flow. This is this one in the graph. We will see in the another title. This unit hydrograph. We can represent the surface runoff and runoff, and we can represent in that graph. So first just you understand this the graph. This is the peak flow. This is the top of the portion. So the peak flow. This is the base flow. Oh, and there are some there are some definitions. Yeah. So we can see in that later that one, right? So right, the continuous process represented with the discrete time steps, right? Right. These are the runoff, right? So first you can understand. So this is a very easy portion if you understand. I will give the question. You can check the answer from this PDF where you can easily understand the portions. So according to irrigation technology subject, these are some very important terms. The catchment area and this one catchment area. Okay, you again and again you memorize that. So PVC people also sometimes they can ask the questions. Previously they asked from our students, but they didn't answer. Right. Okay. Types of catchment: the fan-shaped catchment, fan-leaf catchment. Right. These are some catchment fan-shaped. These are the leaf. You already heard about the leaves. Leaves, so tree leaves like that. So this is like stream. It's just like a river for prototype. This one, the river and the branch portions there. In the river is flow, the water is branched. Some portion, these are some branch. So you can understand the fan shape structures. I think you have some little bit time for an exam. Right, you study well. Exam is not a problem. I think I have the today or tomorrow I will give the assignment. So you have to do, and you have to send in 15th, coming 15th. I will give only 5 days or 3 days time to study, to write the assignments, because I give the PDF and everything. Just you write. So you study the assignment. I heard about in earlier latest UGC also UGCO online study is not worth for students or something. I heard about the so okay, no problem. Anyhow, everyone has the phone and everything. I will upload this video through YouTube. Study well. Uh, However, if you write, you can understand. I need to set that exam paper also. Right, and we will see a next part. Unit hydrograph. The unit hydrograph. The hydrograph. I will ask the question. What's the hydrograph? Normally, you know graph. It's the graph showing the rate of flow versus time past a specific point in a river or other channel, a conduit carrying flow. It can also called as a graph showing volume of water reaching the particular outflow, right? Such hydrographs are commonly used in the design of sewerage. So it's a main requirement for design of sewerage. So you know sewerage, sewerage pit, sewerage or drainage pit. These are the more specifically the designs of surface water sewerage systems and combined sewers, right? These are the some common parts. This I already show that the graph, unit hydrograph. This is the peak discharge. This is the peak rainfall and normal base flow. This and falling limb, storm runoff, like time, approach segment. Right? We will see the definition each and everything. Uh, Right, the rising limb of hydrograph, also known as concentration curve, reflects a prolonged increase the discharge. So normally you know discharge from a catchment area. I already explained the catchment area. It's a very important term. You study well this one. Typically in response to a rainfall given, recession or falling limb, the recession limb extends from the peak flow rate onward. The end of storm flow, peak flow or direct runoff, and the return to groundwater derived is often the recession of falling limb. The recession limb extends from the peak flow rate onward. The end of the storm flow and the return groundwater derived is often taken as the point of inflection uh, of the recession limb. The recession limb represents withdrawal of the water from the storage built up in the basin during the earlier phases of the hydrograph. The peak discharge, the highest point on the hydrograph when the rate of discharge is greatest. The lag time interval from the center of the mass of rainfall excess to the peak of resulting hydrograph time to peak. The time interval from start of the resulting hydrograph, the discharge, the rate of flow, the volume per unit time passing a specific location in a river or other channel. So this is the part of the unit graph, each and everything marked. So falling limb, normal flow, this base flow, and approach segment, right? So this is the definitions. So hydrograph usually consists of a fairly regular lower portion, lower portion. Uh, Lower portion that changes slowly throughout the year and the rapidly fluctuating components that represent the immediate response to rainfall. The lower slowly changing portion is termed base flow. The rapidly fluctuating component is called direct runoff. So this is the portion of unit hydrograph. They marked everything. This one, the rainfall losses, rainfall excess, inflections, This is the base flow and inflection point. So we can make the graph from the recording of rainfall records. So we can make the graph. Some of the assumptions are there. Some of the assumptions, unique assumptions, right? So we can draw this graph. Right. Unit graph, unit hydrograph, the amount of runoff resulting from one unit, 1 centimeter, 1 millimeter, 1 feet, etc., or rainfall excess is essentially a tool for determining the direct runoff response to rainfall. Wants to know the water set area, water set management, you study that. Water set and response to one storm, you can predict what its response for another will look like. The basic I already mentioned, what are assumption of unit hydrograph. When you ask the question, what are the basic assumption of the unit hydrograph? The effective rainfall is uniformly distributed its duration. The effective rainfall is uniformly distributed over the whole drainage basin. The base duration of the direct runoff hydrograph due to an effective rainfall of unit duration is concerned. The ordinate, what's the meaning? Ordinate of the DRH, direct runoff hydrograph. You will see there what is the meaning. The DRH are directly proportional to the total amount of DR of each hydrograph for given basin. The dry runoff hydrograph due to given period of rainfall reflects all the combined physical characteristics of basin. Right? These are some graphs. This is a calculation part, you can understand. Derivation of the unit hydrograph from a given DRH of flood hydrograph. In a typical 6-hour storm, 4 centimeter excess rainfall is occurring. The flow recorded in the catchment as shown below. Derive and unit hydrograph for 6-hour storm. Assume base flow is the 100 cubic meter. In a 6-hour storm, we have to convert it to 8-hour storm. How it is possible? We will see. This the flow recorded in the catchment as shown below. Derived unit hydrograph 6-hour storm. Assume base flow is 100 cubic meter per second. Compute the DRH ordinates of the flood hydrograph minus base flow. The step 2, compute 6-hour unit hydrograph. Column 4, the ordinates of UH, ordinates of DRH or excess rainfall. The observed hydrograph meter cube per second to the direct runoff hydrograph DRH meter cube per second. The observed hydrograph direct runoff hydrograph. Okay, ordinates of UH. Observed hydrograph 100 meter cube per second. Direct run of hydrograph. So how to make this graph? Already they given this one and this data is given and time for 06 these are the time, right? Step 1, compute the DRH. Step 2, 6 our unit hydrograph column. Ordinates of UH. What's the meaning UH? The unit hydrograph. Ordinates of the DRH is rainfall. So first time they mark the time not 6, 12, 18, 24, 30, 36, 42, 48, 54, 60, 66. Observed hydrograph meter cube per second. They put 0 here. The 6 here. Then how to come this 200? They at 100 plus 100. So this is the standard procedure to calculate. We can't ask the reason why it's come the 0, 0. This is the standard method adoption. So you know force is equal to mass into acceleration. We can't ask the question how to come if summation is equal to ma. So already derived that equation. So we can't ask the question. So likewise, so we put 0. This is 0. 200. How to come 200? 100 plus 100, 200. 200. How to come 600? 100 plus 100. 300 plus 100, 400, 500. Base flow is the 100. So sorry. 100 plus sorry this one 100 you can add the 100 plus base flow 100 to 100, right? 100 plus 100 the first 100 plus 100 200, then 300 plus 100 plus 100 plus base flow 600. Okay, you understand? Here 700 plus 700. How to come this 600? 600 okay. 700 plus base flow 800 plus 100 900. This one. Okay. You can understand this one. I will explain this later. Sorry, I explain again. So you see this one, I understand everything. A derivation of the unigram given DRH is very simple. You can simply you deduct from this one. DRH or flood hydrograph. In a typical 6-hour storm, 4 centimeter excess rainfall is occurring. The flow recorded in the catchment dash zone below derive and unit hydrograph for 6-hour storm. Assume base flow is 100. So you have to deduct the 100. So that's why they are mentioning here. Compute DRH means ordinate of flood hydrograph minus base flow. So they given here 100. So you have to deduct. So that's the column 3. Compute 6-hour unit hydrograph. How to calculate the ordinates of unit hydrograph, ordinates of DRH divided by excess rainfall. They already given the 4 centimeter. So you have to divided by this one. So you can simple, very simple calculation. So you can understand, right? This data they already given the time, note 6, 12, 18, 24, 30, 36, 42, 48. This one also they already given. So we have to prepare these two columns. The first one is the direct run of hydrograph DRH, meter cube per seconds, then ordinate of GH. So you have to deduct the 100 values, because 100 is the excess base flow. So we already see that's a base flow. What is the base flow? This is the base flow. So how to make this graph? Already we see we have some assumptions, basic assumptions of unit. The rainfall is the intensity, it's a unique, and time is a unique, and everything is a unique. Some assumptions are made. It we make the graph, right? Okay. Awesome. The compute 6-hour graph, right? So how to calculate? They deduct the 100 base flow, and 100 meter cube per second. 100 minus 100 0, 100 minus 100 0, 300 minus 100 200, 700 minus 100 600, the 1000 minus. So everything we deduct the 100. So 0. Previously I told something, it's the wrong thing. This one correct. So you have to deduct the base flow value, right? Then you have to divide it by the excess rainfall. Excess how much? This is a 4 centimeter. So you have to divide 0 divided by 0, 0 divided by 0, 200 divided by 450, 600 divided by 150. This 225, 225, 175, 125, 75. So this is the very simple calculation. I may ask a question to exams, so you study well this one. Okay, right. Then another one, derivation DRH of flood hydrograph. From given hydrograph, the coordinates of the 3-hour hydrograph is given below. Assume base flow how much they are given, 15 meter cube per second, and derive and DRH for 2 centimeter, 6 centimeter, and 4 centimeter excess rain. This one also very simple, only deduction and multiplication, and this one is a division, right? We can see this is the already they given this calculation. Time, not this one, ordinate of 3 are this one. So you have to prepare the table. Derive the DRH. DRH, what does it mean? Direct run of hydrograph. You have to derive this one, the 2 centimeter and 6 centimeter and 4 centimeter excess rainfall, right? We already given this data, column 1 and column 2. So one time ordinate of 3-hour unit hydrograph, 0 0, 3 12, 6 75, 675, 9 132, 12 180, 15 110. So we have to prepare the third column. 2 into 2, why? DRH due to 2 centimeter ER, right? ER, what is the meaning? ER. UH means unit hydrograph, ER means excess rainfall. DRH, direct run of hydrograph, due to 10 to 2 centimeters. So you have to multiply with 2, with column 2. So 12 into 2, 75, this one, you have to multiply 2. Multiply by 2. Then 4 centimeter, 2 into 6. DRH due to 6, so you have to multiply with this one, right? Then 4 centimeter, so you have to divide, multiply with this column. So 2 10 into 4, how much? 840. Then gradually decrease. There's 70, 32, and so in before this value already gradually increase. But after this value 840, they decrease this one. So simply you can understand. So right. So this one okay. Uh, so you can understand it's only multiplication values. So or you have to convert the GH to DRH with the excess rainfall, right? So the excess these are the Simon assumptions, unique assumptions. Multiple, not the field value not like that because rainfall excess is not unique to centimeters. It may verify time to time. Sometimes rain not rain. Sometimes increase to 2 to 3 and time to time uh, change may change. So but we assume 2 centimeter with the right. Everything is SMS. So calculation of the sorry not calculation the design of structure, so we have to assume and we have to calculate. So when we construct the water tank in our house, everything we make the small assumption how many persons, how many liters consumed. So everything dimensional as per the consumption of the water. If the school, if we consider the school, the water tank size is higher, but the consumption of water is higher. So as per the design consideration, we have to multiply this. Okay. You can understand this one, right? The derivation of the THR unit hydrograph from the DHR unit hydrograph. If the unit hydrograph of specified unit UH is available, then we can derive of any other duration UH by using superpositions techniques. We will see what's the meaning of the superposition technique. But the use of this technique is limited, i.e., if the required duration integral multiple of given durations unit UH, then this technique is easy to use and compute. For example, derivation of 16-hour unit hydrograph given 4-hour UH, then superposition technique is applicable. But when it is to derive for our unit from given 16-hour GH, then this technique should be used. The ordinates of 3-hour UH is given below. I assume base flow is 15 cubic meter per second. Derived the 9-hour UH. So they are given 3-hour unit height. How to the base flow is the 15 cubic meter per second. Derive the 9-hour unit hydrograph. So we have make some assumption. We will have to make the graph with simple superposition method and multiplication and reduction method. We will see. Right. They are given time and ordinate of the 3-hour units hydrograph. So step 1, what they are telling. See the given duration and required duration. Given duration GH is equal to 3 hour. Required duration 3 hour. So 9 is the integral multiple of 3. The superposition technique is applicable. So 3. Step 2. If we add the 3-hour GH by 3 times, then we got the 9-hour. So this is a very important thing. You see if we add 3 our unit hydrograph by 3 times, then we got 9 hour. So 3 hour plus 3 hour 3, right? Then at the same, when we adding the 3 hour hydrograph 1 centimeter, resulted hydrograph will be DRH because excess, but the same when we adding the 1 centimeter each, right? There's the second step like ordinates of given unit hydrograph by 3 hour and then again leg by 3 hour, column 3 and column 4. At this leg unit hydrograph column 6, this will gives us DRH of 3 centimeter ER. Divide column 6 by 3 centimeter because we want to plot GH, right? You will see this is the first column. They are already given data. There's a time and out ordinates of 3 hours, right? The unit hydrograph need to give us seconds. It's not 3. So every gap just get between 3 hours. 3 hour gap analysis, right? 3 hour intervals they are. Then this is the given data. Unit hydrograph liked by 3 hour. This is the superposition method. You see, this will come up, sorry, down. So the node 12, 15, 30, 32. Then here we leave that the first pace and this come from there. Then likewise, like by 6 hour. Everything's assumption. They assumptions they make this only for the design purpose. They do this calculations. So actually, it's not the correct values, right? Actually, they consider this is one, right? 3 hour, 3 hour. So DRH due to sum of the 3H centimeter. So we have to add these values to this column 2, 3 plus 4, 3, 0, 0, 0, 12, 0, 0, 75 to plus 50, 12, 30, 87, right? This one, right? Okay. Then ordinate of 9 hour unit hydrograph. So you have to divide by 3, right? This is the standard method. Unit ordinates of 3 9. So you can find the values of ordinates of 9 hour unit hydrograph. Very simple calculation. You understand? I will give this PDF. Very easiest. Hmm? Simply adding, subtracting, multiplication. You understand? Right? How to convert the UH to DR with the given ER. ER, what's the ER? ER means extra rainfall, right? Okay, we'll see later. Study well this one. I will give this PDF. I think paper setter is myself for postcoding. I don't know. I didn't get any proper information. Paper setter is myself for course coordinator. He should she should give the proper information. After that, I will set these papers. Yeah, right. If I set so no problem. Uh, then no, I think right. I didn't get any proper information about the visiting lecturer setting the paper or course coordinator setting the paper. In our colleges, sometimes if sitting lecturer set the paper or head of the department set the papers. So time to tell things. Right. I will coordinate with her. Okay. We'll see. Thank you.